You know why I'm putting sub C on everything, right? Because it's about its center. So Chris, we're up to you then. For the thin circular plate, I sub xc is equal to what?
1/2 m times r squared.
Great. How about I sub yc?
Oh, you're asking me still?
Yeah,
1/4 mr squared.
Okay. Everybody okay? So first you need to know what kind of shape you're designing, and then you just pull it right off of here. Remember on this page, for second moment of area, I had you cross out one. I had you cross out the whole column, because I want you to just focus on what is the second moment of area about the center. Notice on this page, there are not two columns, because they finally realized it's only important to know what the first column is. Okay? It's only important to know what it is about the center.
Oh, Joanne?
Yes.
So where did you say the derivations were? Like,
They're in my packet.
They're in your
also in the
packet.
textbook.
Okay.
Okay, so now, so Karen, if we want to find the moment of inertia, and now I'm just going to say, well, I don't want, well, I'm not going to just keep saying it. If we want to find the second moment of area or the moment of inertia about a body through its centroid, how are you going to figure out what equations you need to use? So let me just say it again.
Yeah.
If we want to find the second moment of area, which we did find some,
Yeah.
and the second moment of mass, which is the moment of inertia, about the centroid, we just found them, right? And how did we know these equations?
Using
Those sheets,
these-
right? So on the sheets, if we want to find the second moment of area or the second moment of mass about the centroid, about the axes going through the center of the body, you look at the sheet. But now, there are times that the axis is somewhere away from it, so we have to figure out what we have to do. Okay? So now I'm writing this up here. So we have the second moment of area, and we have the second moment of mass. And what's another name, Eric G, for the second moment of mass? Kyle? A moment of inertia, no second. Moment of inertia. Chris, M? Could I also call this moment of inertia? Yes, it's been accepted that we could call this moment of inertia too. So when we want to find these things, not through the centroid, not through center, let me just say center, not through center, we have to do something that's called the parallel axis theorem. I'm going to just write two parallel lines. Parallel axis theorem. And the parallel axis theorem says that the moment of inertia about any axis is equal to the moment of inertia about the axis through the center plus y bar squared times the area. And now what does y bar, what does this mean? This is the perpendicular distance between the axis through the center and x bar. Okay, I'm going to come over here, and I'm going to erase all these equations, okay? We already know them, they're on our sheet. And I'm erasing guys too, because they're on our sheet. So here's x prime, here's my body, here's the xc the axis that's going through the center, here's some other axis, and what the parallel axis theorem says, this is the parallel axis theorem. Parallel axis theorem says the moment of inertia about any axis is equal to a moment of inertia about the axis going through the centroid, the center, which we already know, right? We look up on the sheets, plus y bar squared times a. What's a represent? The area of the body. What does y bar squared represent? The perpendicular distance between the x sub c and the x prime axes. So show me where is x bar here? The perpendicular distance between y bar, sorry. Y bar is the perpendicular distance between the two axes in question. Again, this is something that's been derived. This is an equation that we're going to need to use. And we'll apply it in a little bit.
So if you were swinging I just have to put this in the real term. If you were swinging a tennis racket, we'll say it's circular, you would have this equation I.
Let's we'll put a tennis ball on a string, because then we have one body.
Yeah, something.
Okay, so
yeah.
tennis ball on a string.
And then the length of the handle, or the length of the string would be this Y bar
That's correct. As long as the string's going to the center
to the center.
of the tennis ball. And does it come out with the same units? We said that second moment of area units has to be feet cubed, feet to the 4. And is this going to give me feet to the 4? Yeah, Chris?
So that